Hello, students. I want to introduce all and any next. So, all and any. So these are functions that take in bools and return bools. Uh, all returns true if all the things are true. Any returns true if any of the things are true. So, for instance, if I take all of true, false, true, true, I'm going to get false because all returns true if they're all true, and they're not all true. But suppose now I try the same with any. Any returns true if any of them are true, and some of them are true. Now, the way all and any work is all will actually not keep checking. As soon as all realizes it sees a false here, it's not going to keep going. I could have a million trues after this false, and it's still going to be false, and all knows that. So all stops checking at that point. And any stops checking as soon as it gets its first true. This can be very useful if you want to have things moving quickly. So let's do some examples with all and any. So let's try to see whether or not, consider the polynomial p of x equal to x cubed plus 3x squared plus 2x. Okay, so we have this polynomial. Is it always divisible by 3? Okay, it's a good question. Now, I can't answer this using Python, really. Why am I asking if I can't answer it using Python? Well, because the way I phrased it, I want to know whether it's true for all numbers up to infinity, and Python will take a long time for it to get to infinity. What I can do is I can check to see if this statement is true for, say, 100 numbers or 1,000 numbers. So let's try to see if it's true uh, for, I guess, the first 1,000 positive integers. So I want to know if this is always divisible by 3, so that always gives me a hint. I want to use all. So is it always true that if I take this polynomial right here, and I mod 3, take it mod 3 for x in the range. I said we're going to take 1,000 numbers. Let's go from 1 to 1,000. Is this always true? And of course, I forgot to do a little multiply here and here because I'm thinking like a mathematician for a second, writing in LaTeX instead of Python. But now that's fixed. Just to show you, go back to the error. Errors are valuable. It's telling us invalid syntax, and it points to the first place where it doesn't make sense. Having a 3 in front of an x is not valid syntax in Python. So it showed me exactly what I did wrong. Python is very, very friendly with its error messages compared to some languages that some of which make you hunt for missed semicolons for hours and hours. One of the things I love about Python is it's very good at telling you what you got wrong. Okay, so is this always true? Yes, for all the numbers from 1 to 1,000, this works. And of course, let's make it even a little more. Let's go up to 10,000, still true. 100,000, still true. So it seems like this is going to be true. This is a proof that it is always true up to 100,000. It's not a proof that it's true up to infinity, but it's a proof that it's true up to 100,000. So let's try the same thing, but now instead of 3, let's see, is it always divisible by 6? And true again. Oh, very nice that it's always divisible by 6. Let's try one more. Let's try to see if it's always divisible by 12. False. Okay. Is it ever divisible by 12? Well, if I want to know if it's ever divisible by 12, I could use any. And yeah, it's telling me sometimes it's divisible by 12. I mean, obviously, if x is 12, each of these pieces is going to be divisible by 12. So you have something that's a multiple of 12 plus something that's a multiple of 12 plus something that's a multiple of 12. It's going to be divisible by 12. But Python just confirmed that sort of obvious fact. So this is some of the stuff that you can do with all and any. And let's try another one. Let's say, is this ever divisible by 7? True. Well, when might this be divisible by 7? Well, that is not as obvious. But what this is telling me is sometimes it is divisible by 7. What's one time? Well, actually, it is pretty obvious because if I put a 7 there, it's for the same reason as before. So never mind. So it is obvious that it's sometimes going to be divisible by 7. Is it ever odd? So let's see. Is it ever odd? When I divide by 2, do I ever get 1? Is this ever going to be odd? The answer is no. You might see why. Maybe not. Maybe it's not obvious right away. This piece is always even. And you can factor out an x squared there, and you'll get an x plus 3 times x squared. I'll let you think about that because that's more of a math question. But this now is telling me, hey, this never happens. It's never true that this is odd. So that's a useful application of using the any function to do this sort of experimental math. Let's try to squeeze in one more example. Let's consider numbers of the form 2 to the 2 to the n. So really big powers of 2, 2 to a number that's already a power of 2 plus 1. So one thing that I could do is I could find out what the first few numbers are. Let's take the set of this for n in range 4. And I see I get 3, 5, 17, 257. So I'm getting some prime numbers here. You can check on your own that 257 is prime. Is this always prime? Oh, by the way, if you don't believe me, what we can do is we can check. Let's take all. And what I'll do is I'll take is prime of this for. So this is always going to either be true or false. And I'm going to check, is it always true? Oh, and I have to reintroduce is prime. So you know what I'm going to do? I'm going to do that right here from simply import is prime. And what this did is I got my is prime function, and it told me that this is always true. So for numbers 0, 1, 2, and 3, this is always true. But these numbers are going to get big, so let's try one more example. Let's go up to, say, 8, and this is false. A very famous mathematician named Fermat thought that these numbers were always prime, and with a nice little line of Python code, we were able to show that was not the case using all and any.